Hi folks, Dr. Drake here from SUNY-ESF, and today we're going to talk about tree diameters, what we can learn by measuring tree diameters, why we would care to do that, and the mechanics of actually how we do it, and some of the pitfalls to avoid when measuring diameters in the field. Alright, so let's talk about trees.
So this is a diameter tape that we use to measure tree diameters. I will call it a D tape or a DBH tape. And I want you to notice that there are two sides of this tape that have different scales. So the side you're looking at there shows centimeters and millimeters that refer to the diameter of the tree. So those measurements have basically been corrected for pi. And the other side of this tape has the linear dimension. So why would we want to measure tree diameter? It's one of the most common measurements we make in forest ecology and in forestry. And so let's say this tree behind me, if we wanted to know its size or its mass, let's say we had a question of how much carbon is stored in this tree, or how many board feet of lumber could I get out of this tree. One thing we could do is we could cut this tree down and we could dry it and weigh it. But that's a lot of time and effort and a lot of work, and then we lose the tree in the forest. It turns out that measuring a tree's diameter is very strongly correlated with other metrics of its size or its carbon content that we might want to know, and it's a simple and easy measurement to make.
So here's a graph showing an empirical relationship between the tree's measured diameter at breast height, here on the x-axis, versus direct measurements of the total mass of those individual trees here on the y-axis. You notice that both of those measurements have been transformed to be on a logarithmic axis, so we've just taken the natural log of both of those. So these are sugar maple trees that were harvested, dried, and weighed, and we intentionally chose trees of a wide range of size to create this relationship. And so there's a very strong correlation between the measurement that we're interested in understanding or the total tree mass, and a very simple measurement to make of trees diameter. This is an example of an allometry. Allometry means other measure, so we take a simple measure thing and we use it to estimate things that we care about that are much more challenging to measure.
So we talk about diameter at breast height, or DBH. And breast height might not seem like a very rigorously defined term because, of course, people are different heights and their breasts are at different heights. But diameter at breast height is always measured at 4.5 feet off the ground. And so this stick I have in front of me is 4.5 feet tall, and I am 6 feet tall, which means that this is relatively high for my breast height. If you are a shorter person, you will need to get in the habit of measuring tree DBH at a height that's higher than your personal breast height. And if you're a much taller person, you'll have to get in the habit of measuring tree DBH at a height that's lower than your breast height. You're aiming for 4.5 feet above the soil surface. So here we have a beautifully large black cherry. Put my 4.5 foot stick down. I'm going to embed my DBH tape in the bark and walk around this tree to get its bangs. So this is a 65 centimeter diameter black cherry tree. A nice, big, valuable tree. And so here I've attached my diameter tape to the bark of the tree so that I can wrap the tape around the tree and make the measurement of tree diameter relative to this zero line. So this tree is 33.6 centimeters in diameter. One of the things to take care with tree diameter breast height tapes is which scale they use. So this particular tape measures its diameter in centimeters and millimeters, which is quite common. Another common metric, particularly in the US, is to measure tree diameter in units of inches. And those units are much more common in applied aspects of forestry. And it is particularly important that you do not mix and match these diameter tapes. If you have a large group of people that are measuring tree diameters, it is very good practice to make sure you're using tapes that all have the same unit of measurement. One of the issues we often have is that the ground isn't completely flat, and I'm on a little bit of a slope. And so if I measured 4.5 feet above the soil surface on this downslope, I would be at a different height than if I measured at 4.5 feet from the upslope area. So common practice is to establish yourself on the upslope side of the tree, to find 4.5 feet of height, and to make the diameter measurement at that height. And so I'm going to wrap the tape around the tree, taking care that the diameter tape is straight, and make my measurement at a diameter at this height, being sure that the tape is flat, it is not twisted, and there aren't any obstructions like branches or vines getting in the way of the measurement at this height. One thing to be aware of when making measurements of tree diameter is to avoid irregularities that are right at that tree diameter height. This could be a branch that exits, or a branch swelling that exits the tree at that height. And so we wouldn't want to measure the diameter at exactly this height, because we would get a value that is too large and is reflective of the swelling. So the common practice is to use your judgment and measure just above or below that swelling. And here I'm getting 28 centimeters diameter. One of the issues we frequently run across are trees that have forks in the stems. Common practice is to treat these as separate trees that are measured separately if the fork in the stem occurs below 4.5 feet tall. So here my stick is 4.5 feet long, and I put it next to this tree, and I'll notice that the fork in this tree occurs below 4.5 feet. So to measure the effective diameter of this entire unit, I'm actually going to measure the diameter of this stem, 14 centimeters, and I'm going to also measure the diameter of this stem, which is 15 centimeters, and I will effectively treat them as if they are two separate trees in this case. Another common problem is we have trees that fork at a height that's taller than the standard 4.5 feet height. And in this case, we essentially treat the tree as if it doesn't fork. We make the measurement at 4.5 feet tall, just as we would before, but we only measure this tree once. So here's an example of a tree where measuring its diameter gives you a kind of a limited view of its ecological story, or the amount of carbon it stores, or its growth rate. And so we have a tree with a very abnormal and a growth section where we have this decayed portion of the trunk lower in the tree, and if I measured its diameter at 4.5 feet, I would get a large number that doesn't really capture its size very well. And so sometimes you have to use your imagination or use your ingenuity and to measure diameter effectively for this tree. And so for this particular specimen, I would actually recommend measuring the diameter above the swollen portion at a much taller height than is typical to capture the effective diameter for the stem above. So it's important to keep your wits about you and be looking at the trees that you're measuring. So particularly if we're interested in measuring total live tree biomass, we would not want to measure this tree's diameter at breast height. If we look up, we can notice that this is a snap-off and a snag that is really not in our live tree category any longer. And so this snag has considerable ecological value as habitat for many organisms, but we wouldn't measure this tree's diameter if our target measurements were live trees.
So to reiterate, we're measuring tree diameter at breast height of 4.5 feet off the ground, or 1.37 meters. We measure on the upslope slide. When the tree forks below 4.5 feet of height, we measure both forks separately. And we sometimes deviate from that height of measuring at 4.5 feet when there is an abnormality or a swelling in that stem at that exact height. So you will develop experience, and as you develop as a professional regarding how to make adjustments in the field that are meaningful and robust to provide measurements of trees' diameters. And we use these for all sorts of ecological questions and applied forest issues. Thanks very much for joining us today. I'll see you next time.